All right, welcome. You ready to stop thinking about code for a little while? Have you seen enough sessions with code perhaps? This session is going to be more about how users perceive the software that you build for them. I'm Billy Hollis, and I've been writing code for money over 40 years now. And I've focused in the last 10 or 12 years on user experience design and native applications on mobile and desktop. And so I've really immersed myself in this subject, so I'd like to communicate some of that understanding to you. Understand that even though I work on native, the principles of user experience design don't really depend upon technology platform at all, because they're based in the way people see and the way they think. It's important because as we move into a new era of, we move into an era, we see this is what people expect these days. Software with a user interface of that kind of quality, well designed, instead of probably what a lot of you have in your systems today, screens that look more or less like this. So how are we going to get from this existing stuff here over to something better? Well, understanding what your users see is a pretty key first step there. Because I see a lot of shops at least going to A/B testing, which is a step in the right direction. But if you don't really understand why your users like A or B, then that makes it makes it more difficult. If you understand what's likely to work well, then you'll fumble through A/B testing a lot less. You'll be able to get to better designs faster. I'm going to show you an example of what a design principle is, but I need to check the audience to see sort of how many of you might have been exposed to this before. How many of you have seen a video in which there are two teams passing basketballs around? One dressed in white, one in black. About 20% of you. So I hope those of you who have seen it will give me a little bit of leeway to show it to the rest of the audience. It's only about 20 seconds. Let me bring that up.
This is an awareness test. How many passes does the team in white make?
Go!
How many did you see? How many passes? 13? Is that pretty much the majority case? Occasionally there's a little bit of ambiguity. People might see 12 or 14, but 13 is correct. Okay, fine. Did you see anything unusual in the video? Something that you weren't expecting? Anybody? A what? A guy wearing a what? A costume. A bear costume? Who saw the guy in the bear costume? Oh, 3, 4? Well, let's see it again. This time, don't worry about the passes.
But did you see the moonwalking bear?
Go!
You didn't see, or many of you didn't see that moonwalking bear because of the way your visual system works. And coming from that is a design principle called inattentional blindness. It has to do with the fact that the area of high resolution in your retina is actually very small. It's about the size of a bottle cap or a coin held at arm's length. That's all the high resolution you have. So what your brain and visual system are constantly doing is shifting it around to what it thinks you need to pay attention to. And the rest is just filtered out. It's nothing more than a convincing fake. And that's true even if you know that principle exists. Let me show you another one. I'm going to show you 3 slides for a few seconds each. Each slide will have drawings of tools that you might have around your house or your workshop. And your task is to tell me how many slides have a hammer on them. You ready? Okay, how many slides had a hammer? 2? That's easy enough to do. Now, How many slides had a wrench? How many pairs of scissors were there? See, you don't know. I'll go back to the slides and see. The wrench is there in the lower corner in this case. The pliers, rather. There's pliers there. All of those tools that you didn't notice because you were looking for hammers, your brain filtered that out. And that is the principle of inattentional blindness. Well, it works for computer interfaces too. So all those crowded screens that you're putting in front of people, they don't see most of it. They only see the thing, they dart around until they find the thing they're looking for, and they focus on that. The rest isn't really in their consciousness at all. That's an example of a design principle because it's based in the way we see, it's built into us. You can't train people out of that. Now, people can get better at looking at crowded screens and get familiar with where the things they need are. So over time, they may acclimate to them. But you can't change the fact that it's the way that they see is that they dart around and they filter a lot of things out. Design principles are based in our visual system. One of them is inattentional blindness. Gestalt principles is another family of those. And then how our visual system uses color and hue is based in our visual system. We'll also talk a little bit about how the visual system sees things it's used to with archetypes and familiarity. So inattentional blindness, as I said, has to do with the fovea. You remember that screen that you saw earlier at the very beginning? If I told you this is kind of a demographic screen for somebody and you've looked at it for a few seconds, who spotted who is it for? Did anybody notice what the name was? Huh? Sherlock Holmes. Yes. That's fine. But did you notice that the further over to the side, to the right side you get, the more it turns into complete gibberish? It's absolute nonsense. Here, I'll show it to you. I'll show it to you again. Now, kind of go over toward the side and you notice, what are dingle plops? Raster possums. I mean, it's just gibberish. It's meaningless as you get over there, but you didn't notice that at first. Your eye tends to start in the upper left-hand corner. That's another design principle called the Gutenberg diagram. And so you recorded some information from there, but you didn't really have a reason to look for anything else, so you didn't look at it. In other words, this is a simulation of what you really saw when you glanced up in that corner. You saw Sherlock Holmes, some of his address, but the rest of it filled in with a convincing fake. Now, what the brain does then is take that small area of high resolution and move it to somewhere else. So if you were looking for raster possums, you might eventually land right there with your fovea. But you think you see the whole screen, and in fact you don't. The area around the fovea doesn't really see that much. So what good is peripheral vision then? Why do we even have it? Well, peripheral vision guides the fovea because it picks up sort of very gross structures it might be interested in. And it detects motion. The peripheral vision does a pretty good job of that. And that implies, from a software perspective, that you don't want to use animation gratuitously. It's distracting, highly distracting. But you might want to use it to signal an error, for example, by wiggling something a little bit, because if it's off in the corner away from where they're looking, we just learned they won't see it. But if you do a little bit of animation, that then signals to guide the fovea to find out why that thing is wiggling, and then the user will perceive it. So as we saw with the hammer example, what you see, what the user see, is heavily influenced by what you expect to see. Let me tell you a real story. Just a month ago, actually, I was at NDC, Minnesota when this happened. They have a parking garage across the street from the facility. And I was on a walk, and I walked into the lower level of the parking garage and went to the elevator to take a shortcut back to the convention center. And I saw this. I'm walking up to the elevator. So I just walked right up to the elevator and pressed that button. Because when you walk up to an elevator, what shape do you expect the button to be? You expect it to be round, do you not? And if you're on the lower floor, you expect to see one button. So the first thing I saw that had one button on it, I just walked right up and pressed it. And the security guy came on and said, okay, what do you want? I could tell by his bored tone that people do this about a dozen times a day. Because if you go and look a little more carefully, that is actually the button to contact the security guard in the garage. The actual elevator button is over to the side. I expected to see a button, an elevator button, and something that wasn't an elevator button just came into my mind as an elevator button. See, your mind frames things. It sees what it expects to see in many, many contexts. So your mental model of a kitchen includes certain things in it: a sink and a stove and a refrigerator. There's been research where they took people through what looked like a kitchen, but it didn't have a stove in it. And the amazing thing is, a large percentage of people afterwards will remember having seen a stove, even though the stove wasn't even there, because of the framing. We can see this sometimes in software when combined with a principle called habituation. When you just go down through the buttons, you'll see that the last one actually is different. I've got this actually in a software form, so we'll kind of go through it. Where is that one? All right. Yeah, right here. So you can imagine some software where the users are doing some things on a screen, and then they press the next button, and then they do some more things, and they press the next button, and they do more things and press the next button. And finally, on the last screen, they do some more things and go to the same place and press the back button. Did you notice that was the back button? I mean, I kind of primed you to see it, so you probably did, but I can guarantee you the average user going through that kind of a sequence will not notice the switch. Now you think, why are you telling us this, Billy? Nobody in their right mind would do anything that stupid. I give you American Airlines. I was trying to get a flight to Texas a few years back. I need you to go away. Where's my slides? And I went to their website, and what you're about to see, probably most of you have not seen it, but what you're about to see was on their website for about 18 months. And I first noticed it when it was pretty new. I went through the website, and went through, you go through steps to do flights. You pick out the flights, and et cetera. And I'd gone through 3 screens at this point, and every screen had a continue button in the lower right-hand portion. Every screen up to that point. So I just went about my business, filled out quite a bit of stuff on top of this screen, scrolled to the bottom, and hit the button right there in that position. And there it is. Start over. Why was that there? Well, I hadn't entered credit card information yet. And they had some conventions that if a button wasn't available to use, they didn't show it, and they made all buttons right aligned. Those two things sound completely sensible in and of themselves, but when you combine them, you get this idiocy. Once you fill out, see, there's the credit card information, and once you fill that out, now the continue button, pay to go on, is in the correct place. But I lost that much work, and I guarantee you that American Airlines was losing money every day that button was like that. It was very, very silly. When we put up things that the users don't care about, they don't look at, they don't read, you have to understand that even though you think you've informed them, you may not have, because they're busy, they have jobs. So you developers put up stuff like this. That there's some kind of security thing going on and they want to warn the user. I mean, your intentions are good, but you don't understand that users don't really understand most of the jargon. And they it probably looks more like this. Their mental model of it is. All they know is they've got to click yes to go on. They've got to click that they want to go ahead. And so that's probably what they're going to do without even understanding what you told them. There are other contextual influences on vision. And a lot of this is around the theme of you see what you expect to see. If I tell you that the following slide is a campus map, you'll see some blocky buildings in it. You ready? There's the campus map. But if I tell you that this is actually a word, now, once your perception shifts, you see the word. You don't think of those blocks as buildings anymore. Did you see that shift in your mind? Yeah. That comes from a design principle called Figureground. The eye, the visual system, decides what's important at any particular time. And it focuses on that. That's the figure. And then what it considers unimportant, it just ignores, filters out. That's the ground. And some of you probably seen the famous diagram that goes with that. What do you see here? Tell me. Faces? Two faces? And some people see a vase. It's about 2 to 1 typically. Once you know they're both there, your mind has the ability to impose a conscious interpretation, and you can switch between those two. So that's Figureground. You use it in software to help people maintain context and direct their attention. We wrote a system back in 2008. This was an edit screen. And notice that the outer edges are a bit darkened out to draw attention to the screen they're working on. That's the figure at that point in time. But if you edit an address, if you press the button to do that, the screen changes to look like this. Notice that the background, the original edit screen has been shrunk and made somewhat gray. We actually animated that in the actual software. And now there's a new figure, a new piece of the screen that your eyes are supposed to pay attention to. And then when we're done, we go back to the way things were. We did that in 2008. You've seen that on websites, though. Twitter does it. If you've got the main screen on Twitter and you're reading your feed, but you zero in on a particular tweet, it looks like this. If you didn't understand why they did that, or you probably intuitively did, that is telling the brain that there's a new figure, a new thing to pay attention to, a new thing that's important. Now, you think, again, gosh, how hard could that be, Billy? I mean, that's pretty obvious, isn't it? Well, how many of you used Visual Studio 2012 and the horrible toolbar that was at the top of it? Anybody remember that one? The team that was just beginning to learn some of these principles read about Figureground, and of course, as typical developers who are kind of code-centric would do, they assumed that the code window was always the figure. Therefore, everything else is the ground. Therefore, we make it subtle, sort of grayed out, not very. But the problem is, now finding things on that toolbar is very, very hard. I used it about 6 months after this was released. I did the code, the button to uncomment some code, and honest to goodness, someone in the audience yelled out, "I've been looking for that button for 6 months." This was just a horrible design, and of course now they've brightened it up, etc. If they had made it so that when you put the mouse over the toolbar, it brightened up and became the figure, then this would have been a perfectly reasonable design choice. But they didn't do that. So they made that mistake. You can be primed by past experience. I'm well known for analyzing the design of elevator panels because we see them all over the place, and they range in design from very, very good to pretty awful. So if you get on an elevator, what shape do you expect the button to be? We were talking about this before. It's the same as when you walk up to it. You expect elevator buttons to be round. Okay, fine. Let me show you an elevator panel and point out something about it. Not only are the buttons round, the placards that give the numbers of the floors are round too. What does that lead to? Well, it leads to people pressing this G and probably hurting their finger. Because remember, they get on the elevator, and how much do they really see? Not that much. They kind of move their eyes until they see what they think they wanted, which is an elevator button. They see that round thing, G, that's where I want to go, and they just press it. And they don't really look at the rest of the panel. And the interesting thing about this particular example is, when they make this mistake, they've already been on the elevator once to go up to their room. This is at least the second time that they've been on this elevator, and they're still making that mistake. And lest you think that particular problem is a rare occasion, and I just happened to catch an elevator panel like that. I was at a very expensive hotel in Las Vegas that had exactly the same problem. Now, there are other design principles about this that we're going to see in a few minutes that also apply, but the fact that we expect round buttons and we see something round and be a button is a big one. We can also use expectation in positive ways, though. If you work in the fuel industry, the fuel distribution industry, you know the shape of a propane tank and you know the color of propane fuel. So that expectation, that experience guides you into understanding exactly what this visual means. If it happens to be a fuel oil tank, kerosene tank, then the shape is going to be different and the color of the fuel will be different, and your experience will guide you into understanding. It guides you in other ways as well. Let's go back to that slide and notice that 0 actually still has a little bit of fuel at the bottom. When I created the first version of this tank, I naively thought, well, 0 means no fuel at all, and I showed none. People in the industry will tell you, no, when the tank is no longer working, there's still a small amount of fuel in the bottom of the tank. So that fits very well with their expectation. Now let's get into some of the Gestalt principles that I talked about earlier. This is based in research of German scientists about a century ago. Let me show you a sign in a hotel that I saw a few years back. Imagine the circumstances, and remember that people get tired. People aren't always at their best. They don't always see as sharply as you might want them to and expect them to. So I get off the elevator with all my luggage, and I see this sign. And I'm in room 207, so I see this, I go 201 to 223, that's where I am. So I see the arrow below that, and I take off in that direction and get 2 doors down and find out I'm going the wrong way. And then I go back and look at the whole sign, and it looks like this. Why did I misinterpret that sign? Why did I go the wrong way? Because the eye automatically groups things that are close together. It considers them to be related in some fashion. So when I saw the range with my number in it, my eye automatically grouped the arrow that was closest to it. And that design principle is called Gestalt proximity. I can figure out the sign even though that design principle has been violated, because I have to go back and look at the entire thing and see all of the sign in complete context. But notice that that takes extra work. It takes extra mental effort, extra cognitive load. One of the priorities we ought to have as developers when we create software for users is to keep their cognitive load to a minimum so that we can speed them up and keep them from being so tired. In software, that manifests in things like this. This is an actual page on Amazon I went to. I saw this thing, and this is about 3 years ago, and I go, wow, what is that, 128 gigabytes for a very good price. Check the box below it, hit the button that says put it in the cart, because you can check several things. And I go over to my shopping cart, and the USB drive isn't there. Can any of you see why? The checkbox for that item is above it, not below it. But that checkbox is further away, therefore my mind did not consider that to be the one. See there, that's a case where the designers failed to take into account that many of the pictures had a lot of white space. But see, the white space in the background of the form of the page, they all merge together. So from the user's perspective, the checkbox below is closer. Gestalt principles come out of the fact that the human visual system needs to see structure in relationships very quickly. I mean, that goes back before primates, all the way into much earlier animals, because that's a survival characteristic, being able to sense and understand your environment very quickly. So we see form and structure in relationship fairly quickly. The word Gestalt from German has no exact equivalent in English, but its form, structure is kind of, in general, the best synonyms that we have. So there are several principles of design based on that, collectively known as Gestalt principles. We just saw proximity. We're going to look at that just a bit more. There's also Gestalt Similarity, common fate, things that move together seem related. Continuity and closure, our eye follows things around in a pattern and fills in gaps when necessary. And then Figureground, which we've already seen. All of those come out of the way visual processing works. Our retina is optimized to accentuate edges and do some other things to start the process of making sense of what we see. And then, on the way from the retina through the optic nerve into the visual cortex, more processing is done. That's stage 2, what's called pre-attentive processing. That preliminary information is assembled into shapes and groups and other structural things, and that only takes a small fraction of a second, and it's unconscious. You don't have to think about it. Now, there is a stage where we impose our experience. That's the third stage. That's called attentive processing, and that's where we bring our experience to bear. But Gestalt principles, for the most part, come from stage 2. As I said, we've already seen Gestalt proximity, that the visual system assumes things grouped together are related in some fashion, and that happens very quickly. And because of that, there are various implications for software. If you put things too close together, for example, it becomes sort of difficult to realize that there's a difference between them, and just accidentally you can press the wrong one. I worked on some software a few months ago, 6 months ago. It was a development environment in which the edit was to edit some code that was behind what you would think of as being an event. And then there was a button next to that that wiped out all the code behind that was on that event. It gave no confirmation. I discovered this when I accidentally pressed it and threw away 2 hours of work. I told them about it. They were my client, and they did put a confirmation in there. But putting things too close together, especially in touch-based systems, is a way to cause more errors. Let's get back to that elevator panel there real quickly. Remember, the people are pressing the G there. There are also other things about this that are wrong because, for example, suppose that I restrict the field down to just being able to see this. There's the placard for 4. Which button goes to floor 4? See, you can't tell from this. You have to see the entire picture to do it. Again, it's possible to figure it out, but it requires extra cognitive load. And it's even worse if you think about a blind person sort of getting the braille off that thing. They can't back up and see the whole elevator panel. So notice now that if we just move the placard close to the appropriate button, the eye would automatically get it to the right place. On that elevator I showed earlier that had that same problem, I got on that elevator. And I was on floor 25, and there was a gentleman standing beside the panel, and he asked me my floor, and I told him he was already in the way. So he pressed the button for floor 24 and began to apologize to me. And of course, you know what I said. Well, let me explain about the design of this elevator panel. Let me tell you about the proximity principle. The proximity principle, as I said, works inside your mind almost totally unconsciously. Let me show you a slide with some 4-pointed stars, and you decide if you see rows of stars or columns of stars. By the way, a lot of the diagrams in this entire section are based on the book by Dr. Jeff Johnson that you see there. So, do you see rows or do you see columns? Yeah, you see rows? Do you see rows or do you see columns? Columns now, despite the fact that that's the same size array, 5 across, 4 down. The only thing different is the spacing. And that's the information your mind uses to decide what the groups are. But proximity is not the only thing your mind uses to group. Tell me what you see now, whether you see rows or columns. Now most people will see rows, despite the fact that that's exactly the same arrangement as we saw columns earlier. Because color can override proximity as a grouping mechanism, as a way that a signal the mind uses to group. That design principle is called Gestalt Similarity. The mind groups things not just by proximity, but also by color and shape and size. It considers things the same color to be related, things the same shape to be related. Size, not so much so, but so there we see color being used for similarity. Do you see rows or columns here? Probably rows. And now it's the shapes. Even though the colors are all the same, the shapes cause your brain to assemble the rows into related groups. We've been using these principles for a long time in things like charting. You can see proximity for a period, similarity over a span of time. And these principles can also be used to make things stand out by varying them a little bit. If I tell you to look for the triangle in this slide, you don't really have to work very hard to find it. Your visual system will zero in on it automatically. The same thing if I tell you to look for the green star in this slide. Now, the fact that that's so easy means that when we utilize these principles, we make it easy for our users to see and find the things they need to. This has obvious application to things like highlighting, to make sure that to draw the attention of the user to something. Let's take a look at this screen. I'll give you a few seconds to find the Z. Let's say 5 seconds. Raise your hand if you find the Z in 5 seconds, okay? Ready? Okay, we've got about 20%. All right, now, how many of you can find the Z now? Yeah. See, it's easy now because we added an attribute that the eye will zero in on, the boldness of the Z. So that's how we use visual signals to help the user find what they want. And if we violate these principles, we confuse the user. This is the app for Southwest Airlines in the United States. And when I got it, I've got that button up there, and it's got GPay and Save to Phone, and they're right there together. Is that one button? Is that two related buttons? And why are they talking to me about GPay? I say I'm afraid to press that. I don't know what that means. That's poor design, violates the principles of proximity. Another Gestalt principle is continuity. The visual system expects certain things to flow like paths in the forest. It expects that they continue on in some kind of regular way. So the eye will follow that pattern until it is interrupted. Breaking a continuous pattern like that will cause the user to notice something. So for example, here is a timeline of the things that a truck driver is supposed to do in a day. This is a prototype of a real application. Why do you suppose that, well, first of all, do you see that the indented item is automatically seen by the eye? You don't really have to work very hard to see that. What do you suppose that's signaling in this case? Well, it's overlapped with the item above it. So we use that visual signal to help people see when they were double booked. Now let's do another little test. And we're going to talk about several of these principles, kind of bringing them together. I'm going to show you a card view of sports equipment items that have things like soccer balls and baseballs and American footballs and such. And I want you to count very quickly. I'm only going to show this about 3 seconds. Count the number of American footballs. You ready? You see 3 footballs? I think most people sort of had the time to spot 3, but how many basketballs? How many baseballs? Soccer balls? See, your eye just filtered that out, as we saw before. Inattentional blindness was one of the big reasons. Let's look at some ways to get around that. We can make the shapes of the sports items much more meaningful if we map their size to their real world size. That is, did you notice that in the previous one that a baseball is the same size as a soccer ball? Well, in the real world, that's not true. So if we scaled things to simulate the real world size, we get something like this. Now, how much easier is it to find the baseballs and the tennis balls? But that's nowhere near all the design principles we could apply. We already know that things that are close together are grouped, and we also know that the visual system assumes things of the same color are grouped. So if we start applying things like that, then we could put that together and get a card view like this. Bring the categories together with the data sorting, make each item in the category the same color. And now the user will be able to find what they need much, much quicker. You can see the comparison between the two right here. We can also leverage the visual system to tip people off about what's important on a screen. It's easy to do that just using size. There are other ways to do it too, color and certain kinds of shapes and signals and icons. But the first line of defense in helping people understand importance is size. And it constantly surprises me that most of the interfaces we have now don't really change the size much, if at all, especially the older desktop corporate apps. They tend to just make everything exactly the same size. We could, look, modern apps give us all kinds of ways to do visual things, but I could change the size in classic Visual Basic in 1995, and yet it just wasn't done. So information importance can be called out by making things bigger, and then if you keep the general color scheme fairly neutral, aesthetically nice but neutral, then you can use color to call things out because the color stands out very well. Here's another screen in that that app that I talked about earlier that does fuel management. It's got a couple of the tanks and the color stands out very well. Notice that the COD in the upper left corner there, that's an American term for collect on delivery, meaning these people don't pay their bills. You have to get the money when you give them the fuel. So we want that to be very easily seen. And then notice just below that, there's a bar with a variety of pieces of important information. When's the last time we delivered fuel to them? How much do they owe us? Those things are bigger than the rest of the screen. And that calls out their importance. It makes them very easy to find. Users are also, well, we saw this actually. Users are primed by goals. You saw that with the footballs. You saw that with some of the tools. Users normally do bring up a view in your application or a page in your website with some sort of goal in mind. And they look for things related to that goal and just filter everything else out. So one of the implications of that is that when you design that view, you should clearly understand what their goals might be. Typically, there are no more than 2 or 3 major actions that they take on a particular view. So before you begin to lay out and design that view, you should know what those 2 or 3 things are. If you do, then you can help the user find the things they want easily. Also, when they're there to take actions or make decisions or accomplish a goal, usually there are 4, 5, 6 pieces of information that are the most important. There might be 25 or 30 things they need to look at, but there are usually 4 to 6 things they look at a lot. You need, again, to figure out what those things are by understanding the user's job, and then you make those easy to find. There are a variety of ways to do that, but the first step is knowing which things that you ought to call out. If you don't know what those things are when you begin to design a view, if you don't know what the most important actions and goals are and the most important pieces of information, you should stop right there and go back and do some more discovery. Talk to some users, look at older software you're replacing, whatever, to understand those 2 pieces of information. Well, I have assumed, up to now, that you're all good people, and we're trying to help the user as best we can, make their lives easy. Well, there are people who aren't like that. They use these principles to subvert the user experience, to guide the users down bad paths that they prefer. This is called evil by design. There's a great book on that with that title. It's highly unethical, but I see even very large companies doing it. For example, the web version of the Google Play Store has a screen that I consider evil by design. I went to get the Hilton app to stay at a Hilton hotel, and it's got all these permissions that it wants. Now, let me explain something to you. A hotel loyalty program has no business having access to my contacts. That's a pretty serious potential for some sort of security breach. I told these people about it and got a response on Twitter, and they still haven't done anything about it as of last week. Well, that's bad enough that the people at Hilton are trying to get access to things that they don't really need. But what's worse in the Google Play Store is notice that what's the thing you notice on this screen? Oh, you see that big old green install button. And the permissions that the app is requesting are on a gray background in a somewhat darker gray text. In other words, visually, they want your eye to slide right past that and get down to the install button. And again, I consider that highly unethical, that they are de-emphasizing things that you ought to use to make a decision. I bank with Citibank in the US. They really, really want me to go paperless. They really do. And I'm paranoid, an old guy, so I like my paper statements. I don't even read them, but I throw them in a box because who knows what happens to their website 6 months from now. So I go in to pay my bill and I get this. And it says, yes, accept paperless. Well, I don't want to do that. And then manage settings. Well, what does that mean? Does that mean that there's not going to be an abort option to keep it the way they are? I mean, I don't know. So I'm not going to punch any of those because I don't know what one of them means, and I don't want the other one. So I'm searching. I just want to go to my accounts. And eventually I discovered that if I press the city icon up in the upper left corner, it will take me to my accounts. But they should have made that much easier. They should have put something there that made it clear that I could go straight to my accounts and skip this. They should have had a cancel button or something. And then to go back in history a bit, many of us will remember screens like this when we installed Adobe Flash Player and they tried to sneak in the Google toolbar. That's evil by design. Other principles that can affect what users expect. Archetypes, which is a form of expectation based on experience and familiarity and habituation, getting sort of used to things. Let's talk about archetypes for a moment, because the elevator had an example of that. You expect elevator buttons to be round. Okay, this is a web page that sort of illustrates the same principle. This was to get internet access in a hotel in Pennsylvania. And I'm punching the thing that says high-speed internet because I want high-speed internet. And that looks like a button to me. That's not a button. See, I happen to have a smaller window, and so when I scroll down to see the rest of it, there's a button down below that says connect for free. But the cosmetics of it are precisely the same as the header. Don't do that. Don't make your headers look like buttons. That is leading the user the wrong way because of their expectation. And I told you about the example there of that elevator panel. I mentioned that earlier, and I meant to mention it here. I forgot. Let's talk a little bit about color, because users don't see color the way you probably think. You've probably seen some of the sort of optical illusion things that come up. All of those balls are actually the same color. I mean, you have to mask out a lot of stuff to see it, but they are actually the same color. Because we don't see absolute color. We see color in relation to the things around it. It has to work that way. Because we need to recognize that apple, regardless of whether it's in the shade, surrounded by leaves, or out in the open, we need to be able to recognize it. We need to be able to recognize threats, whether they're in bright sunshine or they're undercover in some fashion. So we see color in relation to things around it. We can see that in this particular diagram right here, where that middle bar is all the same shade of gray. But as you can see, with the different gradient, it's being compared by the eye to different shades of gray. Therefore, it looks like it has different colors in it, even though it does not. Here, I'll show you that. I've got a program for that. So that's what I took the screenshot from. I can make that gradient background invisible, and now you can see it's all gray. I promise you, I did not change that rectangle. And I have a blue version of it as well, that the blue looks different based on the background, and when I take it away, I realize it's all monochrome blue. So understand that color is perceived in relation to other color, the colors that are around it. You've probably seen a fairly famous diagram that was done by one of the researchers. You ever seen this one? Blocks A and B are actually the same shade of gray. They look different because of the shadowing effect of the cylinder. That's a natural aspect of the way that the eye perceives the environment. If I mask out everything but a piece of the A and a piece of the B, then you see that they are the same color. But you absolutely can't see it when it's like this because of the surroundings. Color perception is also affected by paleness, the size of the patch that you're working with, and the separation between two colors. Let's look at a couple of those. I've got a color here, and now if I show you that and then I show you this, are those the same color, or how close are they? See, very hard to tell because they're pale. They're actually somewhat different, but you have to pretty much put them together in order to see the difference. Hard to tell the difference in color because of the paleness. Difficult to tell the difference in color there because of the size. Small and thin. If I make it a little bigger, it's a little bit easier to see. And if I make it that big, it's very easy to see. Where does that come into play? Well, what are some of the thinnest things in your user interfaces? What's the most common thing in your user interface that has thin shapes in it? Text. And that means that color differentiation in text is hard to do. If you're going to do, well, let's say, a color for visited websites and a color for not visited websites, don't make them too close together. You should use entirely different color families, in fact, because the eye will have difficulty discriminating between two similar colors in text because of the thinness effect. Some other scenarios, if you're going to do legends on charts, I see this mistake all the time. Don't make those little b squares, especially if the colors are in the same family. People can't match the colors on the legend to the colors in the diagram. Make the swaths of color in the legend nice and big so that it's a lot easier to match to the actual data. I saw that there really wasn't quite enough difference in color in the Opera browser, and this is even better than it used to be. This is a relatively new version in the last few weeks. And notice the headers, the tabs. Now remember, tabs are thin. There's problems with thin. So I noticed that my Opera, that I was having trouble when I used Opera, telling what was the focus tab, what was the current tab, because the color variation between the one that was focused and all the others in their dark theme just wasn't enough. They have increased that. But Edge has done a better job there, even though I think that brown color is ugly. They've at least made it a clear differentiation for which tab is actually the active tab right now. So if you're going to use color effectively, keep your theme subtle so that the color as I mentioned, the signaling of color will stand out. Don't make the color too bright even for signaling. That's a common rookie mistake, is to make the signal colors very bright. It's tiresome to look at bright colors all the time. Use very subtle gradients for a natural feel. I don't know if you noticed that the Fuel app has a lot of gradients in it. Check the culture, as if you saw the session yesterday by Adam Kogan on his experience in China. There, good is signaled with red, not with green. And in general, you can get a much more effective use of color by getting a professional. And while getting good UX design people that know interaction is hard, getting people who understand color and layout is not nearly as hard. So you can get a professional if it's really important. Color blindness is something that we may have to contend with if our user population is pretty big. By the way, it doesn't mean a person can't see color. It just means certain pairs of colors are hard to distinguish. And color blindness, by the way, affects about 5% of the typical user population. There are several kinds, but really the only one you have to worry about because it predominates is red-green color blindness. And those users have trouble distinguishing certain kinds of red from certain kinds of green. They also, though, can't really tell dark red from black very effectively. And they have trouble telling blue from purple and light green from white. Now, you can get these pieces of software that will, if you give it an image, it will simulate what a colorblind person sees. And that's pretty nice if you really want to take a lot of effort to find out what your colorblind users are seeing, but there is a little bit of a shortcut. You can get a rough idea of the problems you would see with color by using some grayscale. So if I put these little fruit card views into grayscale, then I get something like this. And we can see that the grapes are kind of fading out because there's not enough difference between them and the dark gray, whereas the orange stands out quite a bit better. So if you're going to accommodate color blindness, vary not just by color family, but also by saturation and by brightness. And that way you can have multiple signals so that people who have full color vision are able to quickly see things. People with color blindness can still see things. It's not perfect for them, but there is enough difference that they can fairly easily see the difference. And use other cues. Use shapes, for example, in addition to color, and that will work for all kinds of users. And then what we're looking at now in most of our, especially desktop apps, if they have to have a color blindness accommodation, we will typically make a separate theme for them. And of course you can do that with web applications as well, so that the colorblind person just applies a theme with the colors specifically tweaked for color blindness. You might make those colors brighter in some respects, and since the regular users won't like bright colors as much, you don't want to do that for them, but you could do that for the colorblind users. But the general principle I have for colorblindness is don't give away the use of color as a signaling mechanism for 95% to accommodate the 5%. What you're trying to do is vary things in such a way with the redundancy that colorblind users have a good experience, but non-colorblind users have an even better experience. The visual system also uses mapping to the real world. We saw that with the size of the sports equipment items earlier. There are other ways that the visual system uses mapping to figure things out and signal you instantly what you need to do and what the meaning of things are. These are two, I haven't put the knobs on yet, but these are simulations of the last two gas ranges, stoves, that I've had. I had the one on the right for 8 years. I have had the one on the left for 26 years. The one on the left is in my current house, and I turned on the wrong burner last month. I do it about 3 or 4 times a year. The one on the right, I lived there 8 years. I did not turn on the wrong burner a single time the whole time I was there. What's the difference? Well, the one on the right has the knobs all lined up. Oven off to the side, but before there, the one on the left has the knobs arranged like this. That naturally maps the function of the knobs to the real-world objects they control, and the visual system and cognitive system will do that automatically. We can also see that when we talk about how we display information. I mean, we can go, look, the data grid has a lot of clutter in it, and that means the eye has to filter out a lot. That's one of the reasons that I tend not to rely heavily on data grids. So we can go with lists using size and things like that to make things stand out. But if we want to really leverage what the visual system does, we can go to a timeline. These are interactions with a customer. So if we put them on a timeline, the individual groups tell us sort of the related pieces that we did service and we had a payment and they were associated, related in some way. It's much easier to find particular groups of interactions if we put them on a timeline. Context can set the expectation for perception. Sometimes the exact same thing looks different depending on context. Fold the napkins, polish silverware, wash dishes, but French napkins, Polish silverware, German dishes, that same word looks different. That same phrase looks different. To help people, one of the things to understand is that we've already talked about the eye tuning things out. The eye particularly tunes out what it regards as noise. So that was one of the reasons why you had trouble with that grid of numbers earlier. It just looked like noise. It appeared to be random numbers, and the brain doesn't want to look at that stuff. The brain thinks that stuff is meaningless by default. Well, that's even true in shorter pieces of numbers. So if I do this, that's kind of hard to parse out, but if I do this, it's an American phone number. If I do this, what's that? But if I do it like this, now what is it? It's a credit card number, yes. Because the real world contains a lot of gibberish, our visual system filters it out, so we need to add structure to help the visual system see those things. It really annoys me that websites, many of them, even today, do not allow users to put spaces in credit card numbers. Because if they're going back to compare that they got the number right, they need those spaces for the comparison. It's 5 to 10 times as hard to compare if there are no spaces, because the brain is thinking that's random stuff that doesn't matter. We can also add hierarchy and structure in text. So we might have something that says, you must supply a date, a location, a number, and you have to read the whole thing and parse it out. It's going to be a lot easier for the users if we do it like this. Have the hierarchies of the information in such a way that they're easy to pick out separately. And we can do that visually as well. It's always bothered me that the Visual Studio Color dialog has the A channel right up against the RGB channels, when in essence it's different. It's got a distinct function from the RGB channels. I think it would be better if they spaced it down a little bit like that. I think that interface would be slightly better. But good UI comes from a host of small things that you do well. Also, when you're designing user interfaces, realize that users can get distracted. You can't design for the ideal. I had a discussion about this, talking about there's an incident in America where Steve Harvey was a moderator of the Miss Universe, and he read the wrong name for the winner. He actually read the second place finisher. Here's what they handed him on stage. Now, if you look at that carefully enough, you'll be able to figure out who Miss Universe is. But remember, he's on stage with somebody talking in his ear and a bright light in his eye, just like I have. And so that was not optimum conditions for him. Your users are going to get distracted too. They may be doing something, and somebody in the next cubicle is talking about some juicy gossip or whatever. So you don't design assuming that they have total and complete focus all the time. Design for distraction. There was a nuclear alert drill in Hawaii a while back. Did you hear about that? Like a couple of hours, just total chaos on the islands. This is the screen that the guy picked the wrong thing from. I believe we could do slightly better than that in design, don't you think? Now, I've mentioned that a lot of these examples come from this book, neurobiologist Dr. Jeff Johnston, Designing with the Mind in Mind. And I mentioned earlier, I do a lot of work in this area, so I've left maybe 2 minutes for questions. Let me shield out the lights so I can see you. Questions? You people look a little shell-shocked. Yes?
Maybe it happened to me that I was on a website and the button I was supposed to press was so big I didn't see it.
He brings up an interesting example. He was on a website, the button was so big that he didn't even see it. Now, there's 2 problems with that. Number one is, if it gets outside the expected range, then you don't notice it. But there's also what I call the Fisher-Price effect. Do you have the toys for kids here with the buttons that are really big but don't do anything? See, if you make a big button, it's almost an insult to the user that they need some giant button. Unless they happen to be working on a touch system in cold weather, trying to, indicate installation of some utility, something. Any other questions? Maybe one more? Is that? No? It's hard to see the hands. There, right there. I'm sorry, a little bit louder, please. What create issue? Oh, yes. It's hard to find. Well, they don't, they're not sure they want to have a deluge of issues, I guess. But yes, there are several places where developers might put their own preferences kind of in front of of the user's preferences. For example, I've seen very, very few systems that have issue reporting or bug reporting easy enough for the user to do it. And since it's not the user's job to report bugs, unless you make it drop dead easy to do it, they won't do it. If they can't find the issue tracking and use it in about 20 seconds, then you're not going to get any useful feedback from them. Okay, I think we're right at the exit time. You're welcome to ask some more questions. I think this is the last session, so we don't have to be in a hurry. So you're welcome to come up here. I have business cards for anybody who would like one, but I hope you've enjoyed the session, and I'll see you around tomorrow.